Hello everyone, welcome to my math class. In this video, we are going to continue with the definite integral, but we will recall some formulas first. We will start with power function y equals x to the power n. When we differentiate, the rule is n times x to the power n minus 1. Then when we integrate x to the power n with respect to x, the rule is x to the power n plus 1 over n plus 1. Since it's indefinite integral, we are going to add c in the end. Also, n plus 1 is denominator. It cannot be 0. Therefore, n is not equal to negative 1 for this formula. We are going to use the following tip to distinguish these two formulas. When we differentiate x to the power n, then we can consider n as a hat. Then we are going to put this hat to front. It's like taking off the hat. Then times x to the power n minus 1. So the power n has been decreased by 1 unit. So in this result, we have multiplication, so n times. Then in the power, we have subtraction. We have multiplication first, then subtraction. For the integration, we know it's the opposite operation of differentiation. So we are going to reverse the order of the operation and consider each opposite operation. When we have minus 1, it will become plus 1. The power of x increased by 1. Then for the multiplication, the opposite operation is division. Using the fraction line, it's like the ladder. X to the power n plus 1 goes to the higher level, will become the numerator, and the denominator is n plus 1. Therefore, we can see for differentiation, the power of x has been decreased by 1 unit. We can link the differentiation to the word decrease. For integration, the power of x has been increased by 1. We can link the word integration to increase. Hopefully, the tip will help you remember these two formulas. Now let's look at the application of the formula in calculating the definite integral. First one, we have definite integral of x to the power 3 from 0 to 2. Then we are going to compare with the formula n equals 3. Then we will have x to the power 4 over 4. Since it's definite integral, we are going to consider the simplest case with c equals 0. Then we are going to record lower limit and upper limit. After that, substitute the values into the function. We will have 2 to the power 4 over 4 minus 0 to the power 4 over 4, and this part is equal to 0 directly. Then the final answer will be 16 over 4, which is 4. Let's move on to part B. Here, the integrand is 1 over x to the power 3. By comparing with the power rule, we know they are not in the same form. Then we will need the index law to rewrite the function as a to the power negative n is equal to 1 over a to the power n. In this case, the fraction can be converted to the negative power. Therefore, we will rewrite in this way, x to the power negative 3. We see n is equal to negative 3. Then the new power will be negative 3 plus 1 equals negative 2. We will have x to the power negative 2 over negative 2. Then recall lower limit and upper limit. Before we substitute the values, simplify the result. We have x to the power negative 2. By using the index law, once again, 1 over x squared. And the previous negative 2, we just keep it in the denominator position. After that, we can substitute the values. Negative 2 times 3 squared minus 1 over negative 2 times 1 squared. The first one, we will have negative 2 times 9. Negative become positive. Now we will have positive a half. Now we can put positive a half to front to obtain a half minus 2 times 9. A half is a common factor. We will have 1 minus 1 over 9. Then we will have a half times 8 over 9. The final result, 4 over 9. Now let's look at part C. Here we have the integrand root x. In order to apply the power rule, we are going to convert root x to the power form. Based on the index law, we know root a is equal to a to the power half. Therefore, the definite integral can be rewritten as x to the power a half dx. By comparing with the power rule, we know n is equal to a half. Now when we integrate, the new power will be n plus 1. Then we will have the result x to the power 3 over 2 over 3 over 2. Then record the lower limit and upper limit. We are going to simplify the expression first. The denominator, 3 over 2, we are going to flip it, get 2 over 3, and it becomes the multiplication. Then for x to the power 3 over 2, we are going to use this index law to separate 3 over 2 to 1 plus a half. Then it will be equal to x to the power 1 times x to the power a half, x times root x. Then we are going to record here. We will have 2 over 3 as a common factor, and substitute 4 minus 1 times root 1. Now we know root 4 is equal to 2, and root 1 is just 1. Then we will get 4 times 2, which is 8. 1 times 1 is 1. The final result will be 2 over 3 times 7 is equal to 14 over 3. Looking at the process, if we can do with the new power separately, the calculation may be a little bit easier. And also, when we have x to the power 3 on 2, use the index law to simplify before we substitute the lower limit and upper limit. These are very useful steps when we calculate the definite integral.